my talk is about the problem with mathematics education in Kenya. Now, mathematics is one of the subjects that is most disliked by students. And the students think that it is not interesting, and teachers are frustrated because, for example, if they go for interviews, and math teachers, when they go for interviews, one of the things they look at is that how is their mean grade in mathematics. And they really get frustrated, not because that mathematics is hard, but because of the problem of mathematics. Parents equally are really frustrated because their students are performing very, very poorly. Now, most people are aware that mathematics is a problem, but they don't know how much more mathematics is a problem. Now, mathematics is also very important in every aspect. But I'm going to demonstrate to you, to show you how mathematics is a problem and how it is very important to everybody. Now, this is a display of the results for Western Kenya, and these are results for 50,000 students who did their KCSE exam last year. And as you can see, we have mathematics here and we have CRE here. So these are the subjects. We have math, chemistry, all the way up to CRE. And this is how we normally grade our students. We normally grade our students as whether they got an E or whether they got an A. Now, these are what we call the box plots. And as you can see, this part here represents half the number of students who did mathematics. Now, on this graph, you can see this is the median, which means that half of the students are getting a grade that is lower than a D minus. So in Western, if we are talking about 50,000, we are talking about 25,000 students getting an E in math. Now, this is followed by chemistry closely, and I just realized that most math teachers are also chemistry teachers. Now, the best subject here is CRE. Now, CRE, as you can see, CRE here is having almost half of the students getting at least a C plus and above. Now, the question I was asking myself, how is CRE taught and how is mathematics taught? Now, one of the major resources that CRE is used, they normally use, is the Bible. And you realize that the Bible is in every home. Every parent at least has some knowledge of the Bible. In the society, everybody has got something he can share with a student with the Bible. What about mathematics? Now, my next graph is showing clearly that 50% of the students get an E and below. Which means that among the 50%, I'm sure we have very bright students who are also getting E's and below D minuses. You can see here that almost 75% are getting a mean grade of D and below. And we have only less than 9% getting a mean grade of A. Now, I managed to separate students according to the way they performed in the compulsory subject, and that included Kiswahili, English, chemistry, and biology without mathematics. And I took those who score an average of 8, which means a B minus and above, and I tried to see what did they score in mathematics. Now, those who get an average of a B minus in those 4 subjects, you'll find that 30% get a D minus and below, which means that we have those bright students also doing very poorly in mathematics. So we can't blame the students here. Now, this says a lot. It says a lot more about the math education than it says about the teacher and than it says about the students. Now, this question, when I'm going to train teachers, I normally ask mathematics teachers this question. Is the average salary of a Kenyan higher, equal, or lower than the salary of an average Kenyan? is the average salary of a Kenyan higher, equal, or lower than the salary of an average Kenyan? Now, this question for teachers, most of them get this question wrong. Equally, the students get this question wrong. And I've been to forums like Mbasu, I've also asked the same question, and most teachers will not get this question. Now, how is math taught in Kenya? We emphasize on the computation state. In fact, we have introduced calculators to help students in calculating. Now, there is one student, in my school we normally insist that when students are doing a math test, we insist that they must have a calculator. And then one day a student challenged me. I went to him, I asked him whether he had this calculator. He told me, I don't have a calculator. I asked him now, how are you going to do math without a calculator? Then he challenged me, he told me, let me do the exam, then we compare those students who are having calculators and those who are not having calculators. At the end of the day, that student did much better than those students who had calculators. But what do we insist in schools? We insist in calculations. Now, the way we teach those calculations cannot allow those students to retain the concepts that they have. Now, I'm challenging you, before this presentation ends, would you try to answer this question? And try and see if you'll get that question or not. Let me repeat the question. Is the average salary of a Kenyan higher, equal, or lower than the salary of an average Kenyan? You have the answer? What's the answer? Equal. Wonderful. We will see that in a short while. Now, in order for students to comprehend mathematics concept, we have to teach the application process of math to the real world around us. But this is something that is very difficult to teach. And why do we teach math to students? We want this student, when this student goes out there, they have gone to a supermarket, they have 1,000 shillings, and they want to buy something without having a calculator or a phone. They can easily estimate that I'm having 1,000 shillings, and at the end of this shopping, I'm supposed to do a shopping of less than 1,000 shillings. Now, in order for us to calculate that mental arithmetic, we have to reorder the curriculum. Now, traditionally, the way we teach math, it is how difficult is it to calculate the concepts that we teach to them. Now, it is very difficult for us, because of the performance, we can see that it is very difficult to put across this point of calculating. Now, this makes it very difficult to pass across the idea of understanding the concept of mathematics rather than calculating. Now, I claim that there is need to emphasize understanding of concepts in order to deepen and broaden their knowledge, skills, and understanding, rather than emphasizing on calculations. Now, with the introduction of ICT, we have an opportunity here. And this opportunity is to help us cultivate the idea of understanding the mathematics processes rather than the understanding. Now, with the availability of technology, we have quite a number of tools. Some of them, we have GeoGebra, we also have what we call CAST, and many other softwares and technology. We can use cameras to help these students to gain understanding of the mathematics concepts. Now, I'll go back to my question and try to see if our friend Kinyanjui got that question or not. I'm going to use a resource known as Computer Assisted Statistics Textbook. It's a free resource. It's a free resource that is online. And we try and see if Kinyanjui gave us the correct answer. And I'm sure you also had answers in your mind, so that we can see how we can be able to answer that question. Now, as it is opening, we have quite a number of technologies. We have the computers, we have the iPads, we have the tablets, we have the iPhones, and many other technological tools that can help us in visualizing whatever the students are learning and whatever we are teaching, improving concepts, in demonstrating, and experimenting, exploring, and investigating. So this is one of the tools I was calling CAST. CAST stands for Computer Assisted Statistics Textbooks, and it's free. So I'm going to move to, and CAST has whatever is covered in our local curriculum, everything is covered in CAST. So we have Statistics 1 in Form 2, Statistics 2 in Form 4, then we have Probability in Form 3. So I'm going to move to centered spread. I'm going to use this to check on the properties of median and mean. First, when I ask teachers that question, they don't realize that that is a mathematics question. Now, we are always teaching about mean and median. Now, the question is the average salary of a Kenyan greater, equal, or lower than the salary of an average Kenyan? Now, in Kenya, we have a group of people who earn very large salaries. Then we have other group, the middle income earners are almost around there. And then we have this group of people. Now, these are 10 crosses, and I would assume that since we have a population of around 40 million, one cross is representing 10 million. Sorry, 4 million. So that we have 40 million. So we have this group of people who earn huge salaries. And then we have this group of people who are trying to earn something. Now, if you check the average salary of a Kenyan, you will add all the salaries of all Kenyans and then divide by the total number. Then the salary of an average Kenyan, you will arrange Kenyans in a line, and then you'll pick the middle Kenyan and take his salary and compare to the average Kenyan. Compare it to the average salary of a Kenyan. Then you'll find that the average salary of a Kenyan is much bigger than the salary of an average Kenyan. Simply because the average salary of a Kenyan is, in this case, our mean, and the salary of an average Kenyan, you'll get the middle Kenyan, is the median. So I'm just wondering if Kinyanjui was correct or wrong. Now, there is also another tool known as GeoGebra. And GeoGebra is a tool that can be used for teaching geometry, algebra, and the latest version you can use it to teach all the topics in our curriculum. So I have a few examples. I'll just choose maybe 2 for demonstration purposes. This is something that I've developed, and I use it to teach a concept of to demonstrate the angle that is subtended by the diameter of a circle on the circumference of a circle. Now, normally when we are teaching, you go to class and you just mention, without technology, you just mention like the angle subtended by the diameter of a circle. The diameter of a circle, the circumference of a circle is 90 degrees, and you move on. But with this GeoGebra, it allows us to demonstrate to students that it doesn't matter where that angle is subtended, but it will always remain 90 degrees. There is also another concept of how we normally call our angles. Now, this angle, could someone tell me how we would call this angle here? Maybe the way we were taught. How are we taught? How can we call this angle here? Like, will you call it angle CDB or angle BDC? BDC. So I'm going to try and check if that is true. So angle BDC. Correct. Now, how would you explain to a student that this angle is supposed to be called angle BDC and not angle CDB? Now, if you do it the other way, angle CDB, it gives you the outer angle. And this becomes very difficult to explain to a student without technology. You have gone to a class and you are explaining the angle is not BDC, it's CBD, but it is BDC. The student does not get what you are understanding because you are just teaching the way you are taught. The way you are taught, it has also been written in a textbook, and again, you do it the same way. So with technology, we have an opportunity now to demonstrate this. Now, if you move this to the other side, everything changes. So if I move this, sorry, so I'm going to click there and move there. Maybe I'll task you to do this as an assignment, to try and explain why this is now 270 and the inside is still 90. It is the other way around now. So that is one of the examples I wanted to demonstrate. And then maybe a last example is differentiating a sine graph. Normally when we go to class without technology, you just say when you differentiate a sine graph, then you get a cosine graph. And this student doesn't understand when you demonstrate a sine graph what is happening. That you are getting the gradient of this line. So this is just a demonstration showing how if you differentiate a sine curve, then you have a cosine graph. And these are some of the examples that I've been using, and it becomes very fascinating to students, and at the end of the day they change their attitude. So I have more examples there. Now, why is this the right time? A lot of studies have shown that the top 3 indicators that correlate with increase in student learning are parents, education, teacher, education, and then the class size. Now, with the coming up of these softwares and technology, I'm sure now Kinyanjui now can be able to explain to his daughter or her son in a better way that the difference between the mean and the median, unlike before, because the resource is there for free, therefore the parent can learn, and when the parents learn, they are able to teach students at home the way CRE is taught at school and at home. So mathematics is taught in school, but it is not taught at home because everybody perceives mathematics to be hard. But with this opportunity now, we will find that even parents will learn and they will become teachers at home, so that when this student lives at school going home and he is stuck somewhere, this parent can be able to Google on his phone and be able to explain a concept in whatever subjects that is there, and the student will get it. Teacher education. One of the challenges on the ground is that teachers are dependent on their textbooks. Teachers are teaching the way they were taught. And that is the biggest problem that we have. And if teachers will allow themselves to learn, and with the coming up of these available softwares, then these teachers will learn and they will have confidence to teach in a different way, because they don't know any other way of teaching. It is just the way they were taught in college, and that is what they are transferring to their students. Then, of course, the class size, I can't mention about the class size, the issue of projection, the issue of using different types of media to enable learning. Why is this the right time? We have champions who are having the goodwill to develop their teaching and learning material. Some of them even can create softwares to help the teaching and learning processes. Now, I claim that given that they have been capacity building the teachers, they have been training teachers, we can take this further by having more teacher trainings on specific subjects. If we choose a subject like biology, have people who are developing content in this subject, and they can go and train these teachers so that the teachers can also pass it to other teachers and students. Now, we also need a critical reform to our math education so that it is dynamic. Knowledge is still changing. Now, some of these resources, when you take them to teachers and students, the students are able to interact with these resources and they learn more. I remember a case whereby I took this resource to a school, and the teacher gave this resource to students, and the student was learning about a box plot, a very simple concept that I've been demonstrating up there. But when they got stuck with that box plot, they took it to the teacher. And since the teacher does not know what a box plot is, the teacher became very harsh to the students, and it ended there and then. Because this is a math teacher, is being challenged by a student. So if our teachers, if we can reform the math education at all levels, so that the teachers that are being trained now can be trained in a proper way, and then we change our math curriculum so that we include things like box plots, and then everybody is able to go through the learning process in a manner that is going to help us all. Now, there are quite a number of initiatives. One of them is the mathematics camp. We have been having mathematics camps in Maseno, where students during the holidays, they come, then we expose them to different ideas in mathematics, both to the curriculum they learn and to things and ideas that they don't learn in class. We also have mini math camps where we have a group of teachers and a group of students visiting schools and talking to students, exposing them to this kind of technology and softwares, and they're able to change their attitude. Then we also have initiatives like African Math Initiative that are out to change the teaching and learning of mathematics education. And how I wish that this spreads to all subjects, so that we are having camps for CRE, we are having camps for chemistry, we are having camps for every subject, and people are going out there to sensitize the students, to sensitize the teachers that yes, we have this technology and it can help us in teaching and learning. So I'm not going to read this. I'm going to let you reflect about this and see if you are going to get the correct answer.